This is Limits at Infinity Part 2. So it's a continuation from our previous video. So we're going to start off with example 2. We've covered example 1 in the previous video. For example 2, we have the limit as x approaches positive infinity, and our function is 7x cubed plus 1 all over x squared plus x. Now remember from our previous video, we learned that when it comes to limits at infinity, our first step is to look at our denominator, identify the term that has the highest exponent of x, and we are going to divide throughout by that term. So we're going to have the limit as x approaches infinity, and every single term that we have will be divided by x squared. Okay, so in the denominator as well. So we have x squared plus x, and we are dividing by x squared. Now your second step is to simplify. So we've got the limit as x approaches positive infinity, and we're now going to cancel out and apply laws of exponents. So in our first term, we've got 7x cubed over x squared. Simplifying, that gives us 7x. In the second term, that's just going to stay as 1 over x squared. In the denominator, we've got x squared over x squared. They can cancel out with each other, and we are left with 1. And in the second term, we have x over x squared. That is going to simplify to 1 over x. Now, our next term is to make use of the limit. So we are going to take infinity and substitute in place of x. Remember that in the previous video, we learned that for limits at infinity, if we have the format 1 over x, and whether it is 1 over x or 1 over x squared, 1 over x cubed, when we substitute infinity, it is equal to 0. So 1 over x squared would become 0, and in the denominator, we're going to have 1 plus 0. Now recall that infinity times any value would remain as infinity. So here we have 7 times infinity, which is going to be infinity, divided by 1, that is infinity. So our final answer for this question is infinity. That tells us that for this function, as the x values approach infinity, meaning that as those x values get bigger and bigger, the y values approach infinity as well. Now, example 3 is very similar to example 2. However, in example 3, we have negative infinity instead of positive infinity. And the function is the same. So we don't have to do the working out again, but let's just change what we have to. So wherever we have the limit, it's now going to be negative infinity. And your first step is the same. We're going to identify the term with the highest power of x. We're going to divide throughout by that term. We're going to simplify, and we're now going to substitute negative infinity. So we have 7 times negative infinity. And recall that your rule tells you that whether x is approaching positive infinity or negative infinity, the answer is 0. So 1 over x squared is now 1 over negative infinity squared, which is still 0. 1 over x is now 1 over negative infinity, which is still 0. However, our final answer is going to be negative infinity. So we have 7 times negative infinity, which is negative infinity, divided by 1, which is negative infinity as the final answer. So if the limit is approaching negative infinity, once you've simplified, you will be substituting negative infinity. Okay, let's look at example 4. For example 4, we have the limit as x approaches positive infinity, and the function is 9x to the power 4 plus x all over 2x to the power 4 plus 5x to the power 2 minus x plus 6. So first step is to identify the term from the denominator that has the highest exponent of x, which in this case we have x to the power 4. We're going to divide throughout by x to the power 4. Okay, so we've got 9x to the power 4 plus x, and we are dividing by x to the power 4. And in the denominator, we have those 4 terms. And we are dividing by x to the power 4. Let's just create a bit of space. Okay. So our next step is to simplify. Now, in the first term of the numerator, we've got 9x to the power 4 over x to the power 4. Those can cancel out and we are left with 9. In the second term, we have x over x to the power 4. That is going to simplify to 1 over x to the power 3. In the denominator, we have 2x to the power 4 over x to the power 4. They cancel out with each other. Second term, we've got 5x squared over x to the power 4. We're going to be left with 5 over x to the power 2. We have x over x to the power 4. That's going to be 1 over x cubed. And lastly, we are left with 6 over x to the power 4. So that didn't change. Now that we have simplified, we can make use of the limit. Okay, so to make use of the limit, we are now going to substitute infinity in place of x. We're going to have 9 plus. We have 1 over x cubed, that's 1 over infinity cubed, which is going to be 0. In the denominator, we have 2 plus, we've got 5 over x squared. Now, let's just talk about this 5 over x squared. 5 over x squared is the same thing as 5 times 1 over x squared. And we know that when we substitute infinity into 1 over x squared, that is going to give us 0. So we actually have 5 times 0, which ultimately is just equal to 0. So that second term becomes 0. Then we have minus 1 over x cubed, that's going to be 0. And similarly, 6 over x to the power 4. If we just look at it, 6 over x to the power 4, that is 6 times 1 over x to the power 4. And when we substitute infinity into 1 over x to the power 4, that is going to be 0. 6 times 0 is 0. So we have plus 0. Simplifying the numerator, we've got 9, denominator we have 2. So the final answer for this question is 9 over 2. That tells us that for this function, as our x values approach positive infinity, our y values approach 9 over 2. Let's look at one more example. Okay, so we're now on example 5. For example 5, we have the limit as x approaches negative infinity. We've got 6x squared minus 1, and in the denominator, we've got 2x squared plus 7x. So your first step is to identify the term that has x to the highest power from the denominator, which in this case is x to the power 2. And part of the first term is for us to divide throughout by that highest power of x. So both terms in the numerator will be divided by x squared. And both terms in the denominator will be divided by x squared. Now we need to simplify. So the first term from our numerator, we've got 6x squared over x squared. Those are going to cancel out, and we are left with 6. In the second term, we've got minus 1 over x squared. Nothing can cancel out there, so that's going to stay as is. In the denominator, we've got 2x squared over x squared. We are going to be left with 2. And in the second term, 7x over x squared, that is going to be 7 over x. Now the next step is for us to make use of the limit. So we have 6 minus. When you substitute negative infinity, we're going to have 1 over negative infinity squared. And remember, the rule states that the limit as x approaches positive or negative infinity of 1 over x is equal to 0. So we know that is going to be 0. We've got 2 plus 7 over x. If we just break it up, 7 over x is the same thing as 7 times 1 over x. 1 over x is going to be 0. 7 times 0 is 0. So that gives us 2 plus 0 in the denominator. So in your numerator, you're left with 6. In the denominator, we're left with 2. 6 divided by 2 is 3. So the final answer here is 3. That tells us that for this function, as x approaches negative infinity, y approaches positive 3.